Hello everyone, we will come back to our discussion about the network layer in data plane. So at this video we will discuss about the IP or Internet Protocol. Okay, so there are several protocols laying in the network layer. So first of all we have the routing algorithms which are implemented in the several routing protocols such as OSPF and BGP, which we will discuss in the next chapter. And also it could be implemented in the SDN controller. And then the results of these routing algorithms is the forwarding table, which will be used to forward the incoming packet into an appropriate outgoing port. Okay, and then another important protocol is called IP or Internet Protocol, which uh, standardize the datagram format, and then there is also addressing and packet handling conventions. And then another quite important protocol is ICMP. Well, we maybe we are quite familiar with the ping command or traceroute. Well, with these commands are actually implementing ICMP protocol. All right, so this is IP datagram format or the IP header. There are several fields in the IP formats. First of all is the version of the IP. We have version 4 and version 6, but then they differ in the complexity of the header formats. And the header length, and then a total datagram length, everything all in all, including the payload and the headers. Okay, so then I'm not going to talk detail about this type of services. Diff serves ECN. Diff serves is another service model in Datagram, which is not best effort, but we can, let's say, define several service class depending on the type of service, like real time and so on. And ECN, this is related to the network assisted congestion control, which we talked about in the last chapter. And then there's TTL, time to live, which is decremented in every hop. So we let's say every time a packet or datagram arrives at the router, this TTL will be decremented. So this has this aims to avoid any infinite loop in the routing. And there is upper layer protocol, which will be coded in some codes. For example, like if you're using TCP or UDP, there are several flags for fragmentation and reassembly. And then there is header checksum, a bit similar to the transport layer checksum. And then these two are the most important fields actually: the source IP address and the destination IP address. Okay, so basically, all in all, we have 20 bytes of TCP headers, which we already had before, and then 20 bytes of IP. So if we combine those two, we have 40 bytes plus application bytes. Okay, overhead. Okay, now let's go straight ahead to the IP addressing structure. Well, as we already talked before, if we talk about the IP version 4, it consists of 32 bits, okay, and then divided into 4 octets or 4 bytes, okay. And what we see in our computer, personal computer, for example, like this, 192.168.1.5. So this is the decimal version of the IP address. All right, so yeah, and then another thing is that we have network part of IP address, network part, and the host part. These are it. Okay, this part, network part, and host part, they are not necessarily to be divided into half. It can be like, for example, 24 bits for network and 8 bits for the host, or 20 bits for the network and 12 bits for the host. I mean, it really depends on how many hosts that we want to allocate in the network. So we'll talk about this later. All right, so this is the binary to decimal conversion. I don't think I need to explain about this to you. And also the other way around, from decimal to 8-bit binary. Okay, so how we implement this IP address? Okay, so this IP address is implemented in each host or router interface. So for example, like in this figure, we have hosts. Like for example, it is your personal computer, or this is a terminal in the lab. So each of the terminal need to have IP address so that they can be addressed, or they can be they can send or receive any packets in the network. And also, I think these are quite clear. Okay, even your own gadgets with the wireless networks, they have IP address. But another thing which most of the students forget is that the interfaces in router, they also need to be allocated with the IP address. So for example, this one router can have different interfaces, and each interface actually belongs to different subnet or subnetworks. So we'll talk about this later, but then every uh, interface in the router will have to be assigned with different IP address. Okay, the interface is connection between host router and the physical link. Okay, okay, this is the interface. When we talk about the interface, it's network interface, right? And the router typically have multiple interfaces, as we talked before, and the host can have one or two. Okay, depending on the on how we configure it. It could have, let's say, Ethernet cable and wireless, 1.0 to 11, and maybe other in network interface card. And okay, we have seen this before, right? So I'm going to skip this. Okay, so how are interfaces actually connected? Okay, uh, the details about this we'll learn in chapter 6 and 7, because this is related to the link layer protocol, right? So for example, like Ethernet, well, if we use Ethernet, then it's the link layer protocol. And also if we use wireless Wi-Fi, for example, this is also in this chapter 7, right? So yeah, Ethernet interface is connected with the switch, Ethernet switches, and the wireless Wi-Fi interface is connected with the Wi-Fi base stations. For now, okay, we are not going to worry about this. Okay, now now we have seen, like there are several parts of the IP addresses. We have network parts and the host part, right? Host and network. And then another thing that is very important is that there are several. Actually, there are two addresses which are reserved. Okay, let's say we have one network. Okay, actually, if we talk about one network, if we define one networks, it is actually we allocate a part of IP addresses from, let's say, from uh, one, or let's say from from any number up to let's say from X, or let's say from 0 up to the total number of IP blocks. Let's say 255 if we talk about 8 bits. Okay, so among all of this, from 0 to 255, we cannot use all of the IP addresses, because there are two addresses which are already reserved for network address and broadcast address. Okay, so the network address is the address at the beginning of the address. Let's say if we have this IP allocated from 0 to 255, then network address will be taking this part 0. Okay, let's say we have this address 10.0.0.0. So this 10.0.0.0 will be used for the network address. Then what about the broadcast address? The broadcast address is the last address, so it will be using 10.0.0.255. This is the broadcast address. Then what about the host address? Okay, host address and the address in between of these two. So from 1 to 254. So these are the host address. And remember, when we talk about, I mean, when we say host, it doesn't necessarily mean to be the host only, like this one, the host, the end system, but it can be also used for for this router interface, because uh, each of interface of the router need to be allocated with the IP address. Okay, right. So there are several ranges of IP address. The host address from 000000 to 223, 255, 255, 255. And then, I mean, if we talk about 32 bits of IP34, which is already limited, and then we cannot use all the available IP addresses, because there are several addresses used for different purposes, like for multicast addresses and for experimental. Well, we talk about some classful IP address. Well, this is not really used anymore at this time, but then this is used in the beginning of when the internet are growing. There are several institutions that they want to have some blocks of IP addresses. Okay, so it is divided into different classes. Class A, B, C. Actually, these three first classes, these are the usable IP addresses. Class D is for the multicast, and Class E is for the experimental. Okay, so we only talk about the first three classes. Class A, um, it is the IP address that range from 1 dot something dot something dot something up to 127 dot x dot x dot x. Okay, so if we look uh, at the octet, the first octet, it is everything starts with it should be 0 0 0 0 0 0 1, okay, up to 0 1 1 1 1 all ones. All right. So okay, now there is also another thing which we'll talk about. It is called the subnet mask. We haven't defined this yet. Okay, the term subnet mask, but we already defined there is network part and host part. Okay, for the class A, the network part is only 8 bits. Okay, and host part takes 24 bits. So what it means is that we have because actually this is 8 bits, not 8 bits, meaning that, I mean, it's not 8 bits, exactly 8 bits, but the first octet is for the network part. Okay, but then since we only take the last 7 bits, we don't want to change the first bit, so the only thing that is allocated to the class A IP addresses are the next 7 bits in the first octet. So basically, we can have 2 to the power of 7 networks. So we can have 128 networks, and in each network we can have up to one. So basically, 2 to the power of 24. Okay, it's like 16 million, and then we need to subtract with 2, because 2 addresses are already reserved for network address and broadcast address. This is how we calculate the number of hosts in each network. All right. So basically, this if we see that any institutions, for example, like Google it has one block of IP address class A IP address. So this means that it can really use all the IP addresses um, up to 16 million to all of its servers, for example, or hosts, right? So there's not so many institutions who have this class A, but then one institution can have up to 16 million IP addresses that they can allocate, to any other. I mean, they can sell it as the service providers, or use for their own purpose. Okay, and then the next one is class B. Class B, it's from 10 0 0 0 0 128 up to 191. Okay, so the first 2 bits are not changed, they're not supposed to be changed. So the only thing that changed are the next 6 bits. Okay, this is for the fact that for the first octet. Okay, and then when we look at the network parts and the host parts, the, the network parts have, the first 2 octets are for the network parts, and the last 2 octets are for the host parts. So basically, in the class B IP addresses, uh, we can have, because we have 6 in the first octet and the 8 bits in the second octet. So in total we have 14 bits, right? So in total we can have 2 to the power of 14 networks. It's around 16,000 something. Okay, and then for the host, we can have 2 to the power of 16 minus 2. Okay, so it's around 95,000 something. Okay, again, minus 2 is because the 2 addresses are already reserved for the network address and broadcast address. And lastly, in the class C IP address, it's starting from 192 up to 223. So in the network part of this class C, it takes 3 octets, and the host part is only 1 octet. So meaning that we can have, more networks in the class C, but then in each network we can only have about 254 hosts. Okay, and this is the most common one that we find in our practical in our case. All right, so yeah, again, we can have because in this part, in the first octet, we use only 5 bits, and then the next 2 octets we have 16 bits, 16 bits plus 5, so we have like 2 to the power of 21 for the network. All right, so I think this is for now. We will continue with the subnetting concept in the IP addressing. Okay, so we'll see you again in the next video.